Okay, before we study about the inverse of trig function, so we need to back into the algebra function first to understand what mean by inverse function. So make sure we understand, then we can, when we learn inverse trig function, a lot easier to understand. Okay, so now let me talk about the most general property of the inverse function. Look like this. When you have the function y equal f of x, right? So now let's say the point on the graph function is a and b. Okay, so that means f of a equal b. When x equal a, the value of y equal b. So f equal b. So now what is this one here? The point here become on the inverse. So on the inverse, in general, just change between x and y. So this one here, the inverse should be b and a. Okay, so that is the most obvious property of the inverse function, the definition. So now, for example, if you plot the point a and b like this, any point a and b like this. So the point a and b. So now the inverse should be b and a, right? So let's say b. Let's say, for example, b is from here to here, become a. So from here to here, okay, that b. And a here is 1, b become b here is equal 1 become x, okay, y become x become y. So 1 2 3 become 1 2 3. So point here should be b and a. So now what else? Let me find something. So for example, if you have the point here in C, okay, the black one is on the f of x, okay, the red one is on the inverse of f of x. So let's put like this right here. So if a and b right here, so C and D, I'm sorry. So the inverse of C become D become C. So I have x equals 0 here, become y equals 0, okay, right here. So x become y. So but D equal negative 1 to here, become C become here. So this one here can be D and C. So you see what look like. So let's take one more. So you have the point here, okay. The point here is E and F. So what the inverse should be. So now we don't need to count anymore. So let me show you. All these points here reflect to the line y equal x, the equation y equal x right here. So this one y equal x here, y equal x here, okay. So now they reflect like this way. So you connect 2 points here. So they make a triangle, and this distance equals this distance. So this point here, the inverse of the other. So also you connect from here to here, in triangle, perpendicular, and the same distance. How to find the point of inverse? Instead of to count how many in it, E become F become E, right? All you need to do is to estimate. You can plot this on here, and you get the triangle here, and the distance have to be the same, okay, have to be the same. So right here, so somewhere right here. So now if you wrap the first function here, look like this, the first function here, so the inverse should look like this, so see that. So now the bottom line is, the conclusion is the function and the inverse reflect above the line y equal x. This one, the equation of this one, y equal x, okay. So that's the property. So now property number 1. So property number 1, this one function f of x. Now the notation here is f inverse of x. Now another remind you about the notation. This one here not a negative exponent. Okay, don't confuse. Okay, let's say. So now f, this is a bad notation, but this means the inverse, the symbol of the inverse of f of x. Okay, doesn't mean f inverse of x equal 1 over f of x. That is wrong. Okay, So now 1 over f of x equal 1 over equal f of x raised power negative 1. This one raised power negative 1 equal 1 over f of x, but this one is not. This one is inverse, okay? That is not a good notation, but we have to accept that. So the inverse, so relationship between f and inverse, first of all, if I have the point A and B, okay, all the inverse become B and A. They switch position between x and y, okay? Then f and f inverse, okay, reflect about the line y equal x. So that is second property, okay? First property, second property. The third one, if I put we call the composite function, if I put the whole function f inverse into f, so when I put like this, f inverse of x, so this one come out to be x, so we will check this property later on. Or I put the whole f inside the f inverse, okay, put the whole map into the inverse function, we will also going to be x. So this is the most basic property of the inverse function, okay? Now the next one, I give you specific function, and we're going to find the inverse of that function, okay? So first of all, let's say y equal 2x minus 3, okay? So this one is f of x, okay? F of x, so equal this. So now how to find the inverse of this one? So first of all, people switch between x and y, and they solve for y, right? But I don't do that way, okay? I change between x and y first, and I solve for y. So or I solve for x first, okay? Solve for x first. For some reason, I don't want to change between x and y, because if you want to find the inverse, you have to change between x and y, right? But I change later on for some reason. So okay, so let's go back to, I say y plus 3 divided by 2 equal x, right? Okay, this one not inverse at all. They are the same. This one y in terms of x, now x in terms of y. Now how to find the inverse of that one? We have to change between y and x. So that's what we have to change between x become y, y become x, right? We change the variable. So finally, I have the inverse in red here. So I change y equal x plus 3 over 2. Now remember, this y here no longer that y. Okay, this y here no longer that one. When after the switch, this y here is the inverse function of that y. If this y equal f of x, this y here become f inverse of x. So this one here is the first property we have to find the inverse. Now we check this property here. Okay, so we check property here, and we check property here by graphing it. So first of all, I check this first. Later on, I show you some. So okay, so now we have the f inverse like this, right? So we have f equal this. So now f inverse, I copy this, equal x plus 3 over 2. Okay, so erase this. Now what if this one f of x, this one f of x, write this. So what if I put the whole f inverse into f of x here? Okay, so what happened? So okay, so I put the whole inverse into here. So I have f of f inverse of x. I put anything in here, I put the same thing in there. So equal, I put the whole thing into here, I put the whole thing into here, right? So equal 2 times x plus 3 over 2 minus 3. Okay, I put the whole f inverse inside the function f. So we cancel 2 here, and 3 minus 3 equals 0, so equal x. Can you see that? So f of f inverse equal x. Now how about I put the f inside, I put the whole f inside the f inverse. So let me erase this. Now I start with f inverse of x like this, right? So I start with f inverse of x equal x plus 3 over 2. Now I plug the whole f into the f inverse. That means I put the whole thing in here. So therefore I have f inverse of f of x equal 2x minus 3. Now I plug into here equal 2x minus 3, replace for the x here, plus 3 divided by 2. Minus 3 plus 3 equals 0. 2x divided by 2 is the subtract, cancel 2 equal x. So this one also check, okay, the property is correct, right? So if we graph this one and we graph the other one, they will reflect about the y equal x. To see what happened, let me graph both of them, okay? Okay, so we graph f of x equal to x plus 3, okay, minus 3, I'm sorry. So we have like this. We start with minus 3 first. 1, 2, 3, minus 3 here. The slope equal to means 2 over 1, right? The slope equal 1, 2, rise over run. So then you have the graph look like this. Okay, the graph look like this. Okay. Now the next one, I graph this one. So f inverse. F inverse of x means f inverse of x equal, let me divide this by 2, 1/2 of x plus 3/2. Okay, so this one, why to set 3/2? I have 1, 2, 0, 3 divided by 2 equal 1/5, right? And the slope equal 1 over 2. So when to set here, I go up 1, go to the right 2, 1, 2. So I get second point. Now I go like this. Okay, then I get the graph like this. So okay, so the point here, the graph here, and this one right here. So the red one is the inverse of the line black one here. So how we know? Well, how we explain f and f reflect, f inverse reflect about the y equal x. So we draw y equal x to see what happened, okay? Or y equal x. So this one here, equation y equal x right here. This one y equal x. Okay, can you see that? Very clear. Very clear. This is reflected to the line here. How to show it? So you pick any point here, you put a perpendicular to that point, and you keep going. The point here reflect to the line y equal x here with the same distance. They share the point, the same thing right here, but from here they reflect from here to here, right angle. So the distance here equal this distance here. How about this? This one 0 and -3 become -3 and 0. So x become y, y become x, and 2 point here reflect to the line y equal x. Can see that very clear. Okay. So now let to do something fun. So let me draw something randomly, and I try to find the inverse. Okay. In the case we don't know about anything about the function, so we just know the graph of function look like this. Okay, like this. So okay, so the function look like this. Okay, something like that. Okay. So how to graph the inverse of that one? So what I do is I draw the line y equal x, right? So like y equal x somewhere right here. So this is the line y equal x. Okay, y equal x over there. So then I reflect to the line, right? This one about one half. I got the inverse this point here. Okay, this one I have the inverse right here, and this point here I have the inverse right there, because we go to the set perpendicular to the line y equal x, right? So look like the same distance. Have 1, 2. So right here I have the point here, and from here to here I get the same distance here, the point right here, and this one here the same distance right here, the point right here. Then I connect all points together like this. So now this one is inverse of the other. Okay, just using the property it reflect about the line y equal x. If they give you this on the inverse, you can produce the function, you can produce the inverse by doing like perpendicular to the line y equal x. Then this on the image of the inverse function to each other.